Hello and welcome back to my YouTube channel again. So in the last video we discussed about the simple linear regression. So if you don't know, you can watch the previous video. We learned about what is simple linear regression, like what is the basic use of it, and I just uploaded the same notebook in my GitHub repo. You can go, I will put the link in the description. From there you can get this notebook from there. So let's move toward the multiple linear regression. So as the name suggests, it's the same like linear regression, but there will be multiple variable. It's like same assumption will be there and everything will be same, but the difference will be like we will have different kind of variable names. So there is like a certain process that we can use to choose what are the right variable for the model. So the first variable is like selecting all the random variable and train on the model, and then follow the step, and like we have to like check which variable is needed. We have to remove one by one. It's like trial and error. So another one is backward elimination. So what does it do is like we there is something called p value. So what we do is we set a significance level of 0.05%. So if you don't know about significance level, you can go and learn more about that bell-shaped curved and everything. You will get to know about what is 0.05%, what is significance level, what is confidence interval and everything. So we train the whole set, like we'll provide all the data to that model, and then we'll check if the p value of that variable is slightly like it's higher than the significance level, then we like eliminate it, otherwise we'll keep it. So we'll like move further, you will get more clarity on this. So let me start this. Again the same thing, we're gonna use this linear regression, and same thing will be there. So let's move ahead. So what we gonna do here is let it run here. So yeah, just import all the necessary library that needed, and we are gonna use a 50 startup CSV here. So how does it look like? So it look like it has R&D spend, admin, marketing, state, profit. So we just have to predict a profit by using all the spends, like on if a company is spending on the sectors, so what how much profit they are generating. So we have to predict that sort of thing. So it's similar to linear regression. We have variable called y equals to b naught plus b naught is nothing but extra that we add here, and this all b1 is coefficient of x1, x2, x3, and so b naught is a constant. Yeah. And again let's check for the null values. We don't have any null values. Then before splitting we just drop and keep, like we remove this last line, because this is what we have to predict, this last value profit. We'll drop it and we'll keep everything, and we'll here we will learn one more thing, that how to encode the variable. Like if we have categorical variable here like state, so how we gonna handle it. We are now showing this shape and everything, so we can see all this variable we are keeping in x and this profit in y. So yeah, if you don't know about x and y, you can watch the last video. And now here, yeah, the fun part is categorical variable. So as I have said you that now we have in our data set we have something called state. So if you have to check like what are the unique of state, so what we can do is we can just control C, and this is, we can see key what are the state dot. And if you don't know about n unique, so what you can do is if you directly at n unique, it will give you number of unique state that you have. So if you want to see what are all the unique states are there, better you can do is like I have to display it so that I can see the data frame too. Yeah, as you can see that we have New York, California and Florida. We have 3 different states. So what we gonna do is we have something called in pandas. If you know pandas, we have something called get dummies. So we use that get dummies and we'll drop the one column. So I will talk more about this thing, like draw first true, because if I have to explain it, see here we have something called Florida, we have something called New York, but here we had 3 states, right? Florida, California, New York. So we are not considering California. Why? Because if it is 0, it is 1, so definitely it won't be California, right? It will be 0, because only one state can happen for one like row. So it's a common sense. We can keep 2 column and we can identify third one without keeping it. So why should we keep it? And it's called dummy trap also. If you read more about it, when you pass this value in the modeling part, then the model get confused, like he will get like 3 different variables, like which one to keep and which one to drop. So we'll see. If you won't drop it here also, we will see in the further part when we check the significance level and the p value. There we have to drop the columns, all the columns, and we have to keep only those columns which is very important to our model. Now we are splitting the data and everything. Now we can see like 0.2 20% of data, like we are keeping it for test and everything, all like train. Now we are like, so here what we doing is we are using this linear regression and we are training this. So multiple linear regression is nothing but a simple linear regression with multiple variables. If you please don't confuse on that. So we are doing the same thing. We are predicting the X test and we are checking the scores. So it's like pretty decent. We have 93% like accuracy score. It's not accuracy, we usually called it score. So it's score. Now the best way to just like visualize this is a regression plot. So what we can see here is that this is X variable, X is profit, and here Y is your predictor variable. So what it is doing, it is fitting the line, the same thing that we have checked there. So the best way to see like if we have to read the coefficients, so I will talk more about this coefficient in the further part and I will come back here. Okay, so what I am doing is I am trying to see which are the features which are more important. So here as you can see that it's in dark color, it's in red, light, and R&D is the most important. So let me prove it also. I'm just taking the feature importance. What I'm doing here is I'm creating a data frame. I'm keeping the features and x dot column, and whatever the reg is nothing but the object variable that I have created. I'm taking the coefficient and putting into data frame, calling it importance score, and I'm sorting it by ascending equals to false, means like I will sort it by more importance score. So if you don't get it, like it is not very tricky, you can rewind the video and watch it again. So it's better, like what we do here is we plot a bar plot with this importance and the feature that we get here, and we try to see which features important. That's called feature importance, that which of the features are very important to the model. So we see that R&D is much important. These are the top 3 important. R&D, admin and marketing spend are the top 3 ones. So to prove this, we will prove by using the backtracking method also. So backward elimination method, what does it use? It's use this OLS, that's ordinary least square method. So what does it do? Like it's take the minus, like subtract this variable and keep the least ones. So what we are doing is we are just appending. So it's nothing but we are converting this X variable into NumPy array so that we can feed into this like stat model.formula.api. It's into that. So we'll import that. We import stat model.formula.api, and we are importing this called OLS. So sm.ols, we are importing it, and we are like using this variable. We are passing all this 0 1 2 3 4 5 means all the features that we had. So if you remember how many features do that we have, I have to go 0 1 2 3 4, right? This all are there. So if I have to give all the 4 features, then what should I write? 0 1 2 3 4. So extra I have given, I guess. I will remove this, I will keep but still 4. I will run this and I will check which of this thing are like most important. Sorry, I will keep 5 also. Wait, I will tell you why. See, what we are doing is we are creating a sort of array. So if I have to add a cell here, so I will tell you why. Because if you have to see the equation of this, it comes like b0 plus b1 into x1, right? So we have to we have to pass this b0. So to take this b0, what we are doing is we are creating a numpy array and we are appending all the ones. So as you can see, np.1, and this the shape is 50. So 50 comma 1, we are creating an array of numpy.1s, and we are converting it as a int value. So now this is the first, it becomes the first column of this whole variable. So if I have to see x, let me plot print x so that you can also visualize that what I am telling. I'm sorry, what I did. Where is edit, undo cell operation? Okay, I have to add a new column, and I will print let me print x. See, now we have all 1 1 1 1 in the first place, and all the other variable like 1.6, 1.3, 3.1 is nothing but all the values like 0 1 0 1 are the last two values. So that's why we have kept like 0 1 2 3 4 5. I guess you got it right. And we are using this ordinary least square method, and we are just calling it. It's like multiple linear regression. First we use linear regression, and on top of it we use multiple linear regression. So what is this? We are just getting p values. So as we have decided all the p values which is greater than significance value, we'll keep it, otherwise we'll reject it. As you can see, this is greater, so this is greater, this is greater, this is greater. So like it's not 0, I guess it's very smaller, so it's like 0.000003. So that's why it's showing 0.00. So what we do is we keep only those values like having a highest. See here it's like where is this value has 0.990, so x5 is like most one. So we'll remove this fifth one, we'll run it again. So if we remove it again we see that the value is bit decreased. But if you have to check again, this is fourth one is 0.940. So again we remove that. Again if we have to check the p value, so it's reducing a bit, but the next big one is x2. So if we have to remove that second one, again we have to check. Again the big one is this x2. So if we remove that 2 1 and we run it, so the first one is nothing but our the constant that we have added, and one is nothing but the R&D that we had. So it's 0 0, so we can't remove anything now. So now we get that conclusion is R&D has the most impact on the independent variable. And the coefficient I was telling about that, I will get back to you after the everything. So coefficient is nothing but, if you have to look around here, so you can see a column called coefficient right here. So yeah, so what does it mean? So if we have, like, assume that this is let me zoom out a bit so that you can also see all this thing. See, so if we have all this feature like columns, okay, and these are the coefficient of all the columns. So what does it mean? That if any time, so every 1 unit increase in x variable, so if you remember the like line equation, y equals to b naught plus b1 x, so every time 1 unit increase in x, the y unit increases by the coefficient. So y is the variable that we have to predict. So every time if we increase 1 unit on x variable, the y variable increase by this much. So if I have to increase like R&D by 1, so like the other variable like profit, if I am assuming, right, like let me assume by this, I know that this one is R&D, right? So if I have to increase R&D by 1, the profit will increase by 0.80, and minus means it will decrease. So if I have to increase what was after this R&D, let me see, this administration. So if I have to increase administration, right, so if I have to increase administration by 1 unit, the profit will decrease by 0.002. I guess you got it right. So yeah, that's all for this video. If you like this video, give us a thumbs up, and see you in the next video. Thank you.